So today I want us to talk about series connection, and I welcome you to this lesson. I want you to get your pens and then run through the questions together and revise, as well as getting to know more about series connections. So the first thing is that under this series connection, you should know that resistors will be connected in the same row. Now if the resistors are connected like the way they are here, 4 resistor connected to the 6 ohms resistor, it means that this circuit is already a series connection. Now there are two important statements or two important things that you are supposed to take into consideration when doing with a series connection. The first one is that the current that flows through the series connection or series circuit is the same at all points, meaning that the current that is passing in the 4 ohms resistor and the current that is passing through the same 6 ohms resistor is the same at all points in this circuit. However, you should also know that the second point talks about the voltage. Now, voltage in the series connection is different at all points. So the voltage that is passing through the resistor 4 and this resistor 6, as well as these other resistors, is different at all points. We are together there. I hope we are together. Now, when you look at this simple question here, we are going to define what Ohm's law is. So Ohm's law states that the current is directly proportional to potential difference, but inversely proportional to resistance, provided the temperature remains the same. However, I want you to also calculate the total resistance. So first of all, you have to pause the video and do the calculations before I can show you how to calculate it. Well, I understand now that you have done your part, and let's now run together through this simple question. So the first thing you are going to do is to write the formula, which is total resistance is equal to resistor 1 plus resistor 2. We are going to end on resistor 2 because in the circuit we have just been given 2 resistors. If we were given the other resistors here, especially that maybe they give us 8 ohms resistor, it means that we are also going to reach resistor 3, and so on and so forth. Now because we have reached 6, we are just going to reach on number 6. So in this regard, let me just try to show you how it is done. Now that we know very well that we only have 2 resistors, and then we shall just use the 2 resistors. So 4 ohms resistor will bring down, and then you add it to 6 ohms resistor. The answer you get when you add the 2, you get 10 ohms resistor. Remember, it is very well and very important that you consider indicating the units at the end of the number that you get in the question. Let's now look at or do the other question, which talks about calculating the current that flows in a circuit. Now, in calculating the current that is flowing in the circuit, we are now going to use Ohm's law. When you use Ohm's law method, we are going to say current or potential difference is equal to current times the resistance. Now we are looking at the current, so you can just try to do what we are calling you divide both sides, or you make current the subject to the formula. So you're going to divide resistance in O, and then you're going to say current is equal to, so our voltage in this case it is 30, and then our resistor is what is 30 volts. 30 volts is for the potential difference or the voltage, and then 10 it is the ohms that we have, the total ohms, because we are dealing with the current that is flowing through the entire circuit and not only one part of the corner. So when you divide 10 into 30, the answer you are going to get is 3 amps. Remember, it is very well and very important that you take note of the units, because without the units, we won't know which one you are answering, and either maybe it's money in dollars, it is something to do with, it can mean anything because this is the number. Now, in this case, it has been specified to say you are talking about the current because current is measured in amps, and that is what you are supposed to do. Further, we are now going to do this calculation. Now, as usual, the way we did on the previous question, which is calculating the total resistance, you first of all paused a bit. This time, again, you have to pause so that you can calculate the voltage in each of the resistors. Meaning, you have to calculate the voltage of resistor 4 and the resistor 6 so that you know which the differences between each of the voltages in each of the resistors. So we are going to use the Ohm's law. So Ohm's law in this case is equal, states that the current is directly proportional to potential difference, but inversely proportional to resistors, provided the temperature remains the same. So this is what we are going to do. So this is Ohm's law. So since we are looking for this, there is no need of trying to change. So we are going to say voltage is equal to our current that we have found, it is 3. And then you're going to say 3 times this, let me just write like this, 3 amps times. Now you go back, we are beginning with the 4 ohms resistor. So where there is R there, you are going to replace it by 4 ohms. And then you need to multiply. So 3 times 4, the answer you get is 12. Now this 12 you are finding, it is the 12. Is supposed to be written in volts. So that is for the resistor 4. The other resistor is 6, so we're going to do the same. Or maybe I may say just finish it up because at least you have the knowledge. What we have done here is what you are supposed to do on that one. Okay, I guess you are doing it. So you are now done, I guess. So let's compare the answers. So you're going to just replace it, and then you just now use the same, because you are saying current flowing in series connection is the same at all points. No wonder here we are maintaining to use 3 amps times. Now when we come to here, we have this resistor which is number 6 ohms resistor. So it is the one that we are going to use here as 6 ohms resistor, and in this case when you multiply them, the answer should give you is 18, and this 18 should be in volts. Well, I understand we have now come to the end of our lesson. All what I can tell is to make sure that you subscribe to my YouTube channel as well as the Facebook page. Remember to share the videos on both Facebook as well as the YouTube, and make sure that you click on the bell so that each time I am live as well as I upload some of the videos, you'll be able to be the first person to get a notification. And make sure that you invite friends, especially on Facebook page. Thank you very much for liking my page and also following me in this lesson. See you next time when I talk to you under parallel connections, where we'll be talking about different things. Remember what you have discussed, 2 points that you have discussed are that in series connection, you need to know that current is able, the current flowing in all points in series connection is the same at all points, as while the voltage is different at all points. See you next time until we meet in the next lesson. Thank you for watching.